Okay, good evening to all. So let us get started. So first of all, I would like to thank all of you for joining this Lean Six Sigma Yellow Belt training. And I hope that all of you will have a wonderful learning experience. So first I will start with a quick introduction about myself and my organization. And then we can just get into the training. So my name is Annamalai. I am basically a BTech engineer from IIT Varanasi, Banaras Hindu University. I passed out in the year 1985, and for 30 years I was in employment, both in the Murugappa group of companies in South India and also the Siemens group of companies in near Kolkata. And after working in the production and quality functions in both manufacturing and IT service company, then I started my company in the year 2015. And for the last 10 years, I am running this company called IceQBS. And we specialize on the customized content development, training, and the project implementation support for the lean management, Lean Six Sigma, and the project management. So I'm a certified master black belt from Indian Statistical Institute in Chennai in the year 2013. I am certified as a project management professional, PMP. I got the certification in the year 2011, and my current certification is valid till 2026 August. And I am also a lead auditor for ISO 9001 2015 from the BVQA in Chennai. So I got my first certification in Lean Six Sigma Black Belt way back in 2004 from RG Consultants from Malaysia. So that is a brief introduction about myself. And I have worked as IceQBS, our company. So we have the customer base include for training. I have conducted the training in L&T Valves, Tata Communication, Standard Chartered Bank, Pfizer Healthcare, and Hyundai Motors, etc. And for consultation, I was working with Amazon in Chennai for 5 years for setting up a Lean Six Sigma infrastructure. And I am also working with Asian Paints in Kadalur and ASLR India Private Limited, the largest manufacturers of ophthalmic lens. And I also consulting for Lennox and the ESAP, the largest manufacturers of the welding machines across the globe. So these are a quick introduction about myself and my organization. And so now let us get started. So first we learn about the overview of Six Sigma. So before going into the overview of Six Sigma, so let me just cover some fundamentals. So all of us really have some problems, right? I don't think there is anyone in the world who does not have any problems, whether it is a personal problem or a professional problem. So let us now try to understand what is a problem. So a problem is an obstacle which makes it difficult to achieve a desired goal, objective, or purpose. For example, we are all working professionals and we are all given targets by our organization in terms of the productivity, quality, on-time delivery, and the percentage of capacity utilization, percentage of absenteeism, attrition, and so on. So we are having some target, and all of us are working towards achieving the target. But whenever you are trying very hard, sometimes you find it that it's very difficult to achieve those targets because of some problems, right? Maybe the manpower is not cooperating, or machines are breaking down, or the material is not coming on time. So because of these various reasons, then we may not be able to achieve those targets. Then we are in the problem. So problem refers to a situation or issue that is yet resolved. So I think all of you agree that we are all having problems in professional life. Okay. So what is problem solving? So a problem solving, any problem will have one or many solutions. So multiple solutions may be there for a problem. So whenever we try to solve the problem, we rule out we just do a brainstorming session and then arrive at what are all the possible alternative solutions we can just take. And then we just rule out the obvious poor option, and then we just focus on implementing some 3 or 4 solutions. And then before implementing, we examine the consequences, whether the action, whatever we are going to take, will really solve the problem. And then whatever the best solution according to our mind, then we will put that into practice, right? So that's what problem solving. So finding the best solution out of the different alternatives which are available, that is the problem solving. So whenever we are having a problem and then we are trying to solve the problems, again, there are multiple approaches are there, and we are going to learn like what methodology or what approach we can take in order to solve what complexity of problems, right? So again, there is no universal approach or universal framework that can be used across the different complexity of problems. So let us try to understand how, depending upon the complexity of the problems, we can arrive at the problem solving methodology. So in order to explain this, assume that now you are entering an orchard having a lot of fruit bearing trees, and your aim is to go and taste the finest of the fruit. So whenever you are entering the orchard, you will find that there are many fruits which are already fallen and they are lying on the ground. And only thing is, you need to just to go there, spend, pick up those fruits and then eat it. So similarly, whenever you are walking through your production floor or in the office, then when you are going through the end-to-end process, right from the raw material storage up to the final finished goods storage or the final inspection, whenever you are walking through, then you will find that a lot of problems are there. You can notice, right? Only thing is, you should have an eye for looking for the problems. So you will find that somewhere the machine is under breakdown, somewhere the material is leaking, somewhere the manpower is idling, somewhere you can see that some rework is going on. So somewhere you can see that some plug is the live wire is actually not being connected properly. So all those type of problems you find, right? So what you need to do, you don't have to think of a rocket science to analyze and solve those type of problems. Just to note down what are all the problems you are having, and then you can just, these are all common sense solutions. So you just for each of the problem, you just list down what are the actions to be taken, and then implement the actions, then the problem will be solved. So like that, I think if each and every one of you go and again analyze and have a deep look at your place, you will find that lot of small problem you yourself can solve without having any necessity for using some complex analytical tools, right? So those type of problem we call this just to do it. So you don't have to use any tools for analyzing or solving, just common sense activities. We call this just to do it. So again, for doing that, again, you need to do a proper Gemba walk. So again, Gemba is actually a jargon. So whenever you want to learn Lean or Lean Six Sigma, then you need to know some of those jargon words. So Gemba means it is workplace. It is a Japanese word. So you just walk through the floor end to end and then look for the problems, list down the problems, and then you take the action. Then most of the problems will be solved. That is just to it. And next one is quick wins. So whenever you are entering the orchard, you will find that there are some fruits which are just hanging in the low hanging fruits, right? Low hanging branches. So only thing is you need to really just stretch a bit, and then you will be able to pluck those fruits and eat it. So similarly, in your processes, many times you will find that there are some problems are there, which just by applying some simple tool like the fishbone diagram or a 5-by analysis or a Pareto chart, then you will be able to solve those problems. So such problems which you can solve by using some very simple tools, we call this a low hanging fruits or quick wins, right? So the just do it and the quick wins, these two are the approach which we use for solving simple problems. When the problem is simple, we can use these methodologies. And lean and 8D, these two approaches are used for solving medium complexity problems. So lean is a methodology for identifying and eliminating waste in the process. So again, it was very popular in Japan during the 1950s, and starting from 2000s, again, you can see that it is now across the globe, it is being implemented, right? So again, we are going to learn about that in detail in the coming slides. And the 8D is actually a methodology which is used for solving repeated issues. In IT term, we call this a incidence management. So if the repeated problem, for example, you are supplying some automobile components to your supplier, and you are finding that at a particular plate, a small crack is coming only for 2 to 3% of items what you are delivering. So again, this problem is existing maybe for more than 6 months or 1 year. Then you can use this structured approach or 8D approach for solving those type of problem. And again, for example, in a IT setup, maybe some servers are quite frequently slowing down, right? Frequently, a particular server is getting slowing down. Then those problems can be solved using the 8D. And the Six Sigma is a methodology that is used for solving complex problems, right? So again, there are three different approaches depending upon what type of problems we are trying to solve. So if you are trying to solve a complex problem in the existing process and existing products, that means a process which is running for more than 1 year and where variability is the issue. So those type of problems we can solve by using the DMAIC methodology. DMADB approach is mainly used for solving re-engineering the processor. For example, each and every process will have its own limitations, right? For example, maybe you are running a process and currently the yield is 95%, and that is the best result you can get by using the setup. So if the business situation warrants that your yield should be 98%, then by this setup, you will not be able to achieve those better performance. So in that case, you will have to revamp or you will have to re-engineer the entire process, and then you'll have to do this. We call this a re-engineering the process. For that, we use a DMAIC approach. So the DMAIC methodology is define, measure, analyze, improve, and control. So we are going to learn about that in depth in the coming slides. DMADB is define, measure, analyze, and design and verify, where you are going to redesign your process or the product. And the CDOV approach is used whenever you want to develop a new product right from the scratch. Concept, design, optimize, and verify. So the Six Sigma is actually a methodology which is used for solving complex problems. So from this slide, you have learned that we can use the different approaches for solving the different complexity of problems. So now we are going to learn about the Six Sigma, some of the basic concepts. So I would like to start with a small story from Mahabharata, one of the greatest epics of India. So one day, Guru Dronacharya, who was teaching the war-related skills to both Kauravas and Pandavas, he called all of them to a river bank, and on a tree, he placed a bird made of clay. And the target given to all his disciples were that they should hit the bird in one arrow. So first came Duryodhana, the eldest of the Kauravas, and when he started taking aim, the Guru asked him, "What are you seeing?" Then Duryodhana told that he is seeing the bird. Again, the Guru asked him, "What else are you seeing?" Then Duryodhana, he wanted to impress the Guru. Then he started telling that I'm seeing the tree behind, I'm seeing the river behind, I'm seeing the forest behind, mountain behind, and so on. And again, the Guru checked whether he was holding the bow properly, whether he was taking care of the breeze that was passing at that point of time, whether his bows and arrows were made of good quality material. But he was not satisfied with the inputs or process conditions of Duryodhana, and he asked him to quit even without making an attempt. So like that, one by one, all the Kauravas and Pandavas came, and the Guru was asking the similar questions, and all the disciples were giving the similar answers, and the Guru asked them to quit even without making an attempt. So last came Arjuna, the most favorite disciple of Dronacharya. And again, when he started taking the aim, the Guru asked him, what are you seeing? Then Arjuna told that I am seeing the bird. Again, the Guru asked him, what else are you seeing? Then Arjuna told that I am seeing the eye of the bird. Again, the Guru asked him, what else are you seeing? Then Arjuna told that I am seeing the eyeball of the bird. Again, the Guru checked whether his bows and arrows were made of good quality material, whether he was holding the bow properly, whether he was taking care of the breeze that was passing at that point of time. And once he was satisfied with Arjuna's inputs were right and the process conditions were right, he gave the approval for Arjuna to shoot the arrow. Then Arjuna took aim, and then he shot the arrow, and it went and bang hit the eyeball of the bird. So even though the story was written few thousands of years ago, the moral of the story is holding good even in the modern day today. The approach, what we call as the process approach, which is the basic principle of Six Sigma. So before trying to understand what is a process approach, let us try to understand what is a process. So process is a set of activities done to convert the inputs into outputs. So in a manufacturing setup, we are having some raw material, and these raw materials are processed through the various machines, and then finally we get the outputs. So it may be the plastic component, automobile components, electronic components, and so on. And in a IT service setup, we have some raw information. So this raw information is processed through the various tools and scripts in the laptops and computers and servers. And then finally, we get the output, what the customer is wanting, right? So that is what is the process. A series of activities that convert the inputs into outputs. So maybe one day you had, let us take the example of the digestion process. So for the digestion process, the input is the food we are taking. So the food is processed through the various organs like the mouth, tongue, teeth, the food pipe, the small intestine, large intestine, stomach, kidney, and so on under various process conditions. And finally, the output what we get is the energy and excreta. So the food is converted into the output, the energy. So one day, maybe you had a problem of stomach indigestion. So you went to the doctor and told him that you have the problem of stomach indigestion. So immediately the doctor will start asking the question like, for how long this you have this problem? When did you have this problem last? So do you have this problem very frequently? And where did you have did you have any outside food in the last few days? So you may then remember and tell him that maybe 2 days ago, you had some pizzas in a outside restaurant, and only after that, this problem has come. Then the doctor will analyze that the problem is because of the outside food, whatever you had, and then he will give the medicine accordingly, and your problem of the stomach indigestion is going to be solved. So this is an example of a process approach. So the process approach says you control the inputs, control the process conditions, the output will always be consistent. So again, I'll write it for you. Control the inputs, control the process conditions, output will be consistent. So this is what Guru Dronacharya was trying to observe in all his disciples. So with all his other disciples, he was finding that either their inputs were not right or the process conditions were not right. So he was not confident that they will hit the target. And with Arjuna, he found that inputs were right and his process conditions were right. So he was 200% confident that he will hit the target. And he gave the approval for shooting the arrow. So any process problems you have, then whatever you may have a lot of process problems, and always some targets you are given, and you are always under pressure from the senior management for achieving those targets. So in your attempt to solve those problems related to the outputs, maybe you don't get time for analyzing what are the problems in the inputs and process condition. But the process support clearly says that whenever you have the problem in output, try to analyze what are the problems in the inputs and process condition. The output will always be consistent. So the second basic principle you need to know when we want to learn about Six Sigma is about variability. Variability is simply a deviation from expectation. So for example, assume the average height of the average Indian, male Indian adults. So even though the average height may be somewhere around 165 to 170 centimeters, but again, you will find that there are some people, few people who are having a height as low as maybe 145 centimeters. And again, there will be some people who will be having a very high height, maybe like 210 or 215 centimeters, right? So same thing is about our weight, even our body temperature, right? The blood pressure. So in our processes, like whatever the outputs we are getting. So again, we are always finding some deviation. So deviation means we always want to achieve a exact value, particular value, but we always don't get exact value. Always some variation should be there. So this variation in any process is inevitable, whether it is a manufacturing process or IT service process or software development process. This variability is inevitable. And as per the previous concept, what you have learned, the variabilities, the variations in the output are caused because of the variations in the inputs and the process condition. And sometimes the variation in the process is too large that we start producing the defective, not meeting the customer requirement. So again, we will take a simple example of taking a 11 millimeter rod and then grinding it to 10 millimeter. So we initially set the machine to get the exact dimensions of 10 millimeters, and then we start grinding, and then we'll find that even though we have set it machine to get exactly 10, we may get around say 9.7 to 10.3 variation will be there. And let us assume that the customer is willing to accept 10 plus or minus 0.5. That is 9.5 to 10.5. So initially your process was good. You were getting 9.7 to 10.3. You are very happy. But suddenly one of the bolt in the machine broke. And because of that, the vibration started increasing. And because of that, the variability increased. And then now your process is producing from 9.2 to 10.8. So that means whatever you are going to produce from 9.2 to 9.5 and 10.5 to 10.8, these are not meeting the customer requirement. So that means your process has started producing the defects. So the Six Sigma just helps you to reduce the variations in the output, reduce the defects by reducing the variations in the output, by reducing the variations in the inputs and process condition. Again, I will write it for you. Six Sigma helps you to reduce the defects. So how does it reduce the defects? By reducing variation in the output. So how do we reduce the variation output? By reducing variations in inputs and process conditions. So for a process which is running at a Six Sigma level, then our defect rate will be only 3.4 defects per billion opportunities, DPFO. So that means assume that the aircraft landing is a process. So across the globe, maybe in a month, around 1 million aircraft landings are happening. So out of this 1 million aircraft landings, only 3 landings are going to be defective. So you know that Indian railway network is very extensive, and every day maybe 1 million signal changes are happening. So out of these 1 million signal changes, only 3 signal changes are defective, right? So such low is the defect level, so that um, the quality is going to be very high. The cost, the efficiency is going to be more. The customers are going to be very happy. Employees are going to be very happy. So that is the reason why most of the companies, they want to implement Six Sigma in their organizations. So this is a typical picture you will get when you complete a Six Sigma project. So assume that this project was done to reduce the scrap in a process. So before the improvement, the average scrap was around 21%. And you can see there was a lot of variation from 15 to 25%. So after doing the project, we can find that the scrap has reduced drastically from 21% to around 8%. And you can see the variability also has reduced. So this is a typical picture you will get after doing a Six Sigma project. Whatever the metric you want to improve, you will find dramatic improvement will be there. And also you will find dramatic reduction in variability will be there. So now let us learn what is Six Sigma. So it is a data-driven structured statistical methodology to achieve the defects per million opportunity of 3.4. So it is a data-driven approach. So whenever you want to do a Six Sigma project, then you need to collect a lot of accurate data from the process. And this data you are going to analyze with the help of the statistical tools to find out some 3 or 4 critical root causes. And you are going to take action only on those 3 or 4 critical root causes so that you'll be able to have a permanent solution for the problem. So this methodology was first implemented in Motorola. Motorola was a US-based company. They were into electronic consumer durables. So they were facing a lot of competition from the Japanese companies. And they rolled out this methodology in 1987, followed by Allied Signals in the 1990. And it was implemented in General Electric from 1990.
Remove the arrow, sir.
Yeah?
Sir, sorry for that. Sorry, please remove the arrow.
Okay. So if you think that a lot of new inventions were made when Six Sigma was implemented, so it was not like that. It was only the consolidation of the existing tools and concepts, right? So already like tools like control charts, the design of experiment, the hypothesis testing, all those statistical tools were already available, but they were actually consolidated and they were nicely packed into the DMAIC methodology, define, measure, analyze, improve, and control. And it was presented as a Six Sigma. So no new concept were developed. It was only the consolidation of the existing tools and concepts. So you can consider that it is a tool speed pass for solving process problems. So for example, whenever you have a electrical problem, you call the electrician. When the electrician comes, he comes with the tools box. In the tools box, he is having a lot of tools for analyzing and solving the problem. So similarly, as a process expert, you are going to be exposed to a lot of quality tools, lean tools, and statistical tools, so that whenever you have a process problem, you can use these tools for analyzing the reasons for the problem, and then you can again use some of the tools for solving the problem. So just like how a plumber or an electrician or a carpenter is having a kit box for analyzing and solving the problem, similarly, as a process expert, you can use the Six Sigma methodology for analyzing and solving process problems. So there are two major driving forces for Six Sigma, the customer satisfaction and financial benefit. So any Six Sigma project will start from identifying the customer who is having some problems with respect to the quality, delivery, or price, and then how we are going to solve those problems and improve their customer satisfaction. And the huge financial benefits are expected from a Six Sigma project because this is a very extensive method of the problem solving. So again, as I was telling you, the Six Sigma is a structured methodology for problem solving. So we are going to use a structured methodology called the DMAIC methodology. So again, this stands for each and every word stands for a particular word. So D stands for define, M stands for measure, A stands for analyze, I stands for improve, and C stands for control. So define, measure, analyze, improve, and control. So these are the 5 stages or 5 phases in a Six Sigma project. So in the define phase, we start with the identifying the customer who is having a problem in our products or services related to maybe delivery, quality, or price. Then we talk to the customer and then try to understand what is the problem. So we listen to the voice of customer. We call it a VOC. We talk to the customer, listen to the voice of customer, and then link it to a critical to X factor. What is critical for him? What is causing more pain to him? So it may be CTD, critical to delivery, or it may be CTQ, critical to quality, or it can be CTC, critical to cost. So whatever is the most painful point for them, we identify that, and then again link it to a measurable metric. For example, if the customer says that maybe your price and your quality are okay, but your delivery is not consistent. So I am bothered about your delivery. So that is the voice of customer. Then linking it to a critical to expected, that is CTD, critical to delivery. And then link it to a measurable metric. So how you are measuring the delivery performance? You are measuring the delivery performance in terms of percentage on-time delivery. So once you have linked the voice of customer to a critical to expected to the measurable metric, then quantify the current status and then fix the target and then define the scope of the project, appoint the project leader, the project team, and then write the business case. What are the benefits you are going to get by doing the project, prepare the schedule, and document all those information in a document which is called as a project charter. So the project charter is the most important deliverable in the define phase. Then during the measure phase, you are going to collect a lot of data. So even before starting to collect the data, we need to ensure that your measurement system is capable of giving accurate data, because we are going to put this data into the statistical tools. And if you are going to feed inaccurate data into the statistical tools, the conclusions, whatever you are going to make, may not be accurate. So in order to get the accurate results, you need to ensure that your measurement system is capable of giving accurate data. So for that, we do an activity called as a measurement system analysis. Then if there is a problem, maybe we have to calibrate the instruments, or we'll have to give some training to the people. And after taking those corrective actions, then we can ensure that we'll be able to get the accurate data. So we collect a lot of data from the process during the measure phase. In the analyze phase, whatever the data we are going to collect in the measure phase, we are going to analyze with the help of the statistical tools, and you are going to finalize the 3 or 4 critical root causes which are having the major impact on the problem. For any complex problem, you will find that even though there may be a lot of causes or contributing to the problem, but only 3 or 4 are going to be very critical. And these 3-4 critical root causes can be validated by using the statistical tools. So validating the critical root causes with the help of the statistical tool, that is a USP for Six Sigma, right? No other process improvement methodology uses the statistical tools for validating the critical root causes. So since you are going to validate these root causes with the statistical tools, then your analysis will be very accurate, and you will be able to find the permanent solution for the problem. So in the improve phase, you are going to take action on those 3 or 4 critical root causes. And in the control phase, you will find that by closely monitoring and controlling 1 or 2 critical inputs or the process conditions, you will be able to get a consistent output, right? So you initially start with some 40 or 50 potential root causes. Then by using the various quality tools and statistical tools, at the end, you will find that by closely monitoring and controlling 1 or 2 critical inputs or the process condition, you will be able to get a consistent output. So before the project was taken up, maybe the problem seemed to be very complex. You didn't have a clue like why the problem was happening. But after doing a Six Sigma project, maybe within maybe 5 to 7 months, you'll be able to find that maybe 1 or 2 critical factors are contributing substantially for the problem. And if you are going to closely monitor and control these 1 or 2 critical factors, then you are going to get a consistent output. So in that way, it's a very beautiful methodology for problem solving. Second is what the approach as I was telling. We start with a fishbone diagram somewhere during the measure phase, do a brainstorming session, find out around 40 to 60 potential root causes. Then by using the various tools, we narrow down, and then by control phase, we will be able to closely monitor and control 1 or 2 critical inputs or the process condition to get the consistent output. So again, Six Sigma, wherever it is implemented, again, we have a clear parallel organization structure is in place for helping the project team and the project managers. So you know that organization structure is very important in any organization, right? For example, if you are having some problem in the salary calculations, then you know that you should contact the HR executive. So if you have a problem in the machines, then you know that you will have to contact the maintenance engineer. So similarly, in the companies where they want to implement Six Sigma, a parallel Six Sigma organization structure is in place so that whenever the project manager or the project team members have any problems, then they know to whom they should go so that the problem can be solved. So the typically it starts with the senior management. That is, we call it the executive leadership. That is the CEO or the managing director. So who is the topmost person in the organization, and his role is very important for the implementing Six Sigma. So he has to have a very strong leadership skills. He has to create a positive environment for cultural change. Because again, till now, the people have been solving problems by using some ad hoc analysis and methodologies. But now suddenly you ask them to solve the problems by the data analysis, they may find it very difficult to change. So it is the responsibility of the CEO to provide a positive environment for cultural change. He has to arrange for training at all the levels. Then the champions or the senior management people who are actually, in order to achieve their targets, they are looking for some methodology for some help. And if Six Sigma is offered as the help, then they will immediately go for that. So they actually provide the administrative support for the Six Sigma project. They select the projects, project leaders and project teams, and they just remove any roadblock or the any roadblocks or the obstacles the project team may face. So that is the role of the champion. And the master black belt is a person who is going to give the technical guidance for the project. So when I say technical guidance, it is not that for a construction company, he is going to give civil engineering related inputs. So when I say technical, related to Six Sigma. So the master black belt is a person who is going to advise the project leader and the project team on what data we need to collect from the process, which statistical tool we should use, and when the output comes, how to interpret the data and make the conclusion. So all those guidance will be given by the master black belt. So to start with, the company can hire an external consultant, and over a period of time, internal talent can be grown. And he also helps the project team and the project managers to just present the projects for the review by the senior management. So as per the methodology, Six Sigma methodology, after the completion of each and every phase, the project has to be reviewed by the senior management, and the master black belt will help the project teams to prepare the documents for the review. And the black belts are normally from the middle management, managers or senior managers who are having a very strong leadership skills. So they take up some projects to solve some complex technical issues by using complex statistical tools, or they can lead some projects needing interdepartmental coordination. So they mentor and motivate the green belts and all the other people who are involved in the project, and they are exposed to all the complex statistical tools. And typically their role is going to be a full-time role in Six Sigma. And green belts are normally from the lower management, engineers, senior engineers, deputy managers, and so on. So they can lead a small independent project in their own department, or they can become a part of the black belt project team. So they are also used to all the statistical tools in all phases, but not as complex tools as black belt. So they normally play a part-time role in the Six Sigma projects. Yellow belts are normally the people, supervisors, and the senior workmen who are always present in the process, and they help the black belt or the green belt project leader for the collection of accurate data from the process during the measure phase, and then for closely monitoring and controlling the critical input in the control phase. So since they are available 24/7, all the 365 days. And white belts are normally the people to whom basic awareness training is given, right? Maybe 2 to 4 hours of training, especially to the people in whose department the Six Sigma projects are taken up, so that they can actively take part in the brainstorming sessions for finding the root causes for the problem. And again, when the solutions are brainstormed, they also can give their inputs. So you can see that the Six Sigma, a parallel organization structure is in place so that whenever a project leader or the project team members, they have any issues, then they know to whom they should go so that the problem can be solved. So now we'll just talk about a bit of lean. What is lean? So lean is a systematic method for identifying and eliminating waste in the process. And it was popular in Japan during the 1950s. So all of you are aware, the Japan in the Second World War was fought between 1939 and 1945, and the war ended when United States of America, they dropped atom bombs on two Japanese cities, Nagasaki and Hiroshima. After the Second World War, Japan's economy was totally devastated, and they were working hard to come out of their problems. The United States of America government, they felt that it is their moral responsibility to help the Japanese people to come out of their economical issues, and they sent a lot of technical experts from various fields to Japan. So some of the quality gurus like the Edward Deming, Joseph Juran, and Phil Crosby. These are all some of the experts who frequently visited Japan and helped them with the latest quality concepts. And the Toyota, who became very active in the 1950s, they took the lead and they were originally implementing Lean. So Lean is a methodology for identifying and eliminating waste in the process. So before understanding what is the waste, let us try to understand what is value. So value is the change in shape or form for which the customer is willing to pay. For example, if you are working for a automobile company and the customer is ordering for a red color car, and because he likes the red color, and you painted the car with red, and then he is willing to pay for that, and the cost of the painting is included in the car's cost. But for example, maybe on a particular day when producing his car, there was a miscommunication, and then some rework has gone in the painting. Because of that, some 20,000 rupees extra has been incurred by the organization. So if you go and ask the customer, then he is not willing to pay for that. So any scrap or the rework, we call that as a waste, right? Anything which is not adding value to the customer, we call it as a waste. So the core idea in Lean is to maximize the customer value while minimizing waste. So if you want to find a slogan for Lean, then you can say Lean means more with less. More with less. That means more output with less inputs, right? So, for example, assume that your currently your selling price is 100 INR, 100 Indian rupees, and your cost price is 10 rupees, sorry, 90 rupees, 90 INR. So that means your profit is 10 INR, right? But if you are going to implement Lean, then you are going to add more values to the customer, more features and functions you are going to give. So the customer is willing to pay more for that. And then say, for example, he is willing to pay 110 rupees. And since you are doing it with the fewer resources, the cost is going to come down to maybe 80. So that means your profit is going to be 30. So that means by implementing Lean, since you are going to produce more with less effort, then profitability is going to be increased drastically. And that is the reason why most of the companies, they want to implement Lean in their organization. And again, nowadays, Lean is becoming very, very important for the organizations, because in the 1970s and early 1980s, when not much of the competition was there, both domestic and international, then if you want to increase the profitability, then you could just increase the selling price, right? For example, these are cost price and these are selling price. So cost price minus selling price is the profit. So if you want to increase the profit in the olden days, then since not much of competition was there, then you just increase the selling price, because there's the customers cannot go anywhere else. They'll have to only come to you. So you just keep the cost price same or slightly higher also, no problem. But if you want to increase the profit, but increase the selling price. But after the 1990s, when a lot of globalization has taken place, you are not only having the local competitors, you are also having some international uh, competitors are there. So even sustaining your selling price, the current selling price itself is going to be a challenge for you. So in this case, if you want to really increase the profitability, then until unless you do something to reduce the cost, then only you will not be able to increase the selling price. Only thing is, if you are able to reduce the cost price, then only you will be able to increase the profit or maintain the profit in the current level. So that is where the implementation of lean will help you. And lean will help you to systematically reduce the cycle time or the process time, reduce the errors, reduce the inventory, and respond quickly to customer needs. So we always call lean as a demand-driven approach. So that means whenever the customer is asking something quickly or something with a better quality, in order to meet his end customer's requirement, then we should be able to immediately adapt to his requirement and meet the customer. So typically we call Six Sigma as a data-driven approach. So Six Sigma is a data-driven approach. Whereas lean is actually a demand-driven approach. Whatever the customers are demanding, we should be able to meet the customer demand. So again, when we talk about lean waste, we have seen that lean means identifying and eliminating waste in the process. So whenever we talk about waste, immediately what comes to your mind is that the scrap, whatever we are doing in the process. But according to the lean, there are 8 different types of waste are there. And these 8 wastes are applicable not only for the manufacturing sector, but everywhere, whether it is IT service companies, software development, or supply chain, logistics, warehouse, everywhere these 8 types of waste are there applicable. And these 8 ways we can remember by remembering the word downtime. So where each letter stands for a particular word. So D stands for defects, O stands for overproduction, W stands for waiting, N stands for non-utilized talent, T stands for transportation, I stands for inventory, M stands for motion, and E stands for extra processing. Right. So again, let us have a quick look at what are the different wastages stand for. So defects means any rework or scrap, whatever we are doing in the process, right? So as I was telling you, any rework is not going to add value to the customer. So that is going to be a waste. And scrap, if you are starting from the raw material and then at the different stages of the operation, we are going to scrap it. Again, that is going to be not adding value to the customer. That is a waste. Any rework or scrap is a defect. Overproduction means producing some items not the for which the customer has not placed the order. So we produce in order to, sometimes maybe we don't have enough orders to fill our capacity. So in order to ensure that our manpower and machines are utilized in a better manner, then without getting firm order from the customer, we tend to produce more and then keep it in the finished goods. So that is not the right approach, because if the customer is not going to place the order, then everything is going to go as a dead inventory or a non-moving inventory, slow-moving inventory. So in order to avoid overproduction, you should always produce items only for which we have firm order from the customer, and we should produce it exactly the right quantity as given ordered by the customer at the right time. Again, you should not deliver late or you should not deliver early with the right quality. So to avoid overproduction, always you produce the right product for which you have the order, right quantity as required by the customer, right time when it is actually required by the customer with the right quality. Third waste is about waiting. So in any setup, you will find that from end to end, different processes are there, and all the processes may not have the same output, right? So one may have better output, higher output when compared to the other. Then whichever is going to have a lower output, again, a lot of the waiting time will be there. So waiting time is again a waste according to the lean. So, and again, if in that process, if there is a delay in getting the raw material or a critical manpower is absent or the machine is under breakdown, again, the stress is going to be more. And in many organizations, the waiting is actually one of the biggest challenge. The fourth one is non-utilized talent. So non-utilized talent means where the talent of the employees are not being utilized by the organizations better way. So I have asked the questions to many of my students in the different batches. I just asked the question, what percentage of your capabilities are being utilized by your current organization? And typically I get it is 50 to 60%. That means 40 to 60% of the individuals' capabilities are not being utilized by the organization. And this is going to be one of the major wastage for any organization. So we need to really see how we can just keep all the employees engaged and then utilize all their talent so that the efficiency can be improved. The fifth phase is transportation. So mainly because of the poor layout. So initially, when we start the operations, maybe we may just our requirement may be quite low, so our layout may be correct. But over a period of time, when our capacity increases, then we tend to keep the machines in the places where the space is available. So after 4 to 5 years, we find that a lot of unnecessary movements are happening. That is going to be a waste because a lot of power and fuel is going to be wasted. And because of the transportation, again, the material also may get damaged and rejected. So again, it is always better to just stop the operation for maybe a week or two, do the complete re-layout of the entire place so that your wastage can be reduced. The sixth phase is inventory. Inventory is where you have added more value in terms of material, manpower, and machine time, but it is lying with you either as a raw material or the work in progress or the finished goods, and you are not able to sell it to the customer and convert that into money. So if your company is going to accumulate a lot of inventory, then the working capital flow is going to be affected. So the company may not have enough money to pay to the salary to the employees and to pay the supplier. So all the money will be blocked as a inventory. So inventory is the biggest enemy as far as lean is concerned. Then the seventh waste is motion. That is, if in a place operator has to stretch a bit in order to load the machine, he has to bend a bit in order to unload the machine, and he has to walk some 50 meters to transfer the material to the storage area. So this bending, stretching, and walking is going to make him tired very soon, and his efficiency is going to be reduced. Similarly, when people are working in a very unfriendly environment, like more heat is there, a lot of heat is there, a lot of dust is there, or a lot of noise is there, or people are made to lift heavy weights, or they are not being given adequate tools. So in that case, then they'll be becoming very tired soon, and their efficiency will be reduced. So in IT setup, we can see that the back pain, the neck pain, hand pain, obesity. So these are all some problems related to the motion, which affect the efficiency of the people. The last one is about extra processing. That means doing more work than what is required by the customer. For example, sometimes you may find that there was a huge quality issue was there that has been escalated up to the customer's MD. Then an additional layer of quality check will be instituted. And again, you will find that even after 3 or 4 years, again, 2 layer of quality control will be doing, which is not really needed. Maybe once or twice in order to ensure, maybe you can do that. But if that extra layer of quality control is going to be a regular practice, then it is going to be not, it's going to be a waste. So in our working area, we need to find or where all these 8 types of waste is there and take action to remove those so that our efficiency will improve. So that is about the 8 ways. And now we are going to use some of the most commonly used lean tools. Kaizen is actually a small improvement, continuous improvement. So again, it is very popular in Japan. So the concept here is small drops of water makes a big ocean. So even a small improvement project, which is going to save maybe 100,000 rupees every year. And if 1,000 people are going to do the 1,000 projects, again, the savings is going to be more. So in most of the companies, it will be implemented as a size and scheme. So an employee can give a suggestion for the any ideas they have. They can just put it in a suggestion box. The box will be open and it will be sent to the manager for approval. And once the manager approves, then it will be implemented and the improvements will be tracked. So again, once in a month or once in 3 months, again, the people who are doing a good job will be recognized and rewarded. So again, the monetary value of the reward is not very important, but the fact that the reward is given by the topmost person in the organization in front of all the employees. So that is going to motivate the people to take active part in that. Pokayoke, also called as a mistake proofing. So basically, it will help you to avoid some manual errors. For example, if you are just starting the car, you just get into the car and you start the car and then you forget to secure the seat belt. After running for maybe 5-10 meters, again, your car will give an alarm saying that seat belt is not secured properly. Until unless you secure the seat belt, the warning is going to come. Again, same thing with the if the handbrake is not released or any of the door is not closed properly. So the Pokayoke will help you to avoid any manual errors, right? Same thing like washing machine shutting off, switched off when somebody is opening in the when they open it in the switched on condition. So whenever you are making some improvement during the control phase, in order to sustain the improvement, then you will have to go for some Pokayoke mechanism. 5S is actually a Japanese word used main for 5 Japanese words starting with S. Seiri, Seiton, Seizo, Seiketsu, and Shitsuke. Seiri means sorting. So you'll have to sort what is required and what is not required. What is not required had to be removed from the workplace, and what is required, you'll have to keep it in a according to the frequency of use. Seiton or setting in order is a systematic arrangement. So you'll have to find a place for everything and everything in place, right? For each item, whatever you are keeping as required, you'll have to find the appropriate place. And at any point of time, anybody goes and checks, that item should always be there only. Shining is cleaning. So you'll have to clean the workplace and the machines on a daily basis, weekly, monthly, and annual basis, so that you keep the machines and the workplace spick and span, help you to avoid the accidents and the reduce the breakdown. Standardize is standardizing the activities, the work we are doing, end-to-end activities. Everyone has to do it in the same, all the activities should be same, in the same sequence, with the same time, so that the output will be consistent. Sustain, in order to sustain the improvement, you will have to put in some control mechanism in place. So again, some audits, 5S audits, and then the recognition rewarding. So these are all some of the ways you can sustain. So 5S is actually a lean tool that will help you to improve the workplace discipline. And Kanban is actually a lean tool which will help you to reduce the is a visual management system for inventory control. So whenever your inventory is going beyond the limits, then you can use this tool. And just-in-time concept is mainly used in many of the automobile components for the assembly of the cars, so that the whatever the material required for the day's production, that will be received in the factory only in the morning, and then in the night when the second shift ends, then it will be delivered out of the factory, right? So at the beginning of the day and at the end of the day, you will find that there is no inventory either at the raw material stage or in the work in progress stage or the finished goods stage, right? So that is about lean. So then we will have a quick look at what are the different tools we use in the different phases. So the whenever we are in the DMAIC methodology, define, measure, analyze, and improve. So in the define phase, whenever we are defining the problem, we just in order to narrow down the scope of the project, then we can use the Pareto diagram, right? So, for example, assume that you are doing a project to reduce the number of tickets in a IT maintenance, right? So, any employee can raise a ticket if they face any hardware or software issue, and maybe every month 1,000 tickets are raised, and a project is taken up to reduce the number of tickets. Then again, the how many tickets are raised because of any defect, that we just collect the data, and then we will find that 80% of the problem are always coming because of 20% of the causes, right? So this rule we call it a Pareto diagram. It was derived from Vilfredo Pareto. He was an Italian economist who lived from 1848 to 1923, and he was doing a research on the how the wealth was distributed among the Italian, and he found that 80% of Italy's wealth was with only 20% of the Italian. So we also call that as a 80-20 rule. And Ishikawa, who was a Japanese quality guru, he used it for problem solving. And then he told that 80% of the impact of the problem are caused by 20% of the causes. So if you are able to identify these 20% of the causes and take action, then 80% of the problem is going to be solved. So the example what we are discussing, so there are 10 possible reasons for which 20 possible reasons for which a ticket can be raised. And we find that out of these 20 causes, only the top 3 causes, there is the mouse issues, keyboard issues, and unable to install. So these 3 itself is contributing to 85% of the number of tickets. So if you are going to take action only on those 3 root causes, then 85% of the problem is going to be solved. So in a defined phase of the Six Sigma project, a Pareto chart is used to narrow down the scope of the project. So again, as I was telling, when I was explaining the DMAIC methodology, the project charter is one of the major deliverable in the defined phase. And there are 6 elements, major elements in the project charter. So again, we need to define the problem, what we are taking for solution in a very crisp and clear manner. So we always start with the problem statement. So the problem statement should contain what is the metric we are trying to improve, what is the current situation, and how long the problem is existing. For example, a typical problem statement may say that currently the percentage on-time delivery is low at 80% based on the data from January to September 2025. The goal statement is what we want to achieve. So again, the goal statement should contain the metric for improvement, what is the target you want to achieve, and by when. So ideal goal statement will be the objective of the project is to improve the percentage on-time delivery from 80% to 95% by March 2026. Business case is the benefits what we are going to get from the project. So in terms of monetary terms, or in terms of, we call this the tangible and intangible benefits. Tangible benefits are those which we can measure in terms of money. Intangible benefits are we cannot measure in terms of money, like employee satisfaction, customer satisfaction, and all. Then timeline, when each phase is going to start and end. Scope of the project. So what is going to be the scope of the project? So if you are talking about the, say, for example, you want to reduce the scrap. So we always try to see like whether it is for a particular product, or whether it is particular for a particular process or a particular customer, and so on. So if you are going to narrow down the scope of the project, then the possibility of successfully completing the project is going to be very good. And then we also have to give the team who is the project manager, who is a sponsor, who is a master black belt, and so on. And then this is going to be a formal document signed by the project leader, the master black belt, the champion, and the finance representative, right? So this gives a commitment from the senior management for the successful completion of the project. So again, a simple case study from my own personal experience. So there was a first day when I saw my daughter had gone to the school after the summer vacation. So when she came back, I found that she was feeling very sad. When I asked her the reason for her sadness, initially she did not say anything. But when I put a lot of pressure on her, then finally she told that she was feeling bad because when all her other friends were explaining about a wonderful experience in an exotic location during the summer vacation, then she was not able to tell anything because she has not gone anywhere outside. I was feeling even bad because I was the one who did not take her for the summer vacation outside. So even though I was earning $120,000 every annum, every year, I for the last 5 years I have not saved even a single penny, and that was the reason why I could not take her outside. So I thought why this problem cannot be solved using Six Sigma methodology. So the define phase, again we start with the identifying the customer. Customer here is my daughter. Voice of customer says that I am feeling sad because I didn't have anything to say. Linking to the metric for improvement, if I had enough savings, then I would have taken her. So savings is the metric what I want to improve. The problem statement, the savings from a salary is 0% against a target of 5% for the last 5 years. Metric we have identified, that is a savings. Current situation 0%. How long? 5 years. Goal statement, again the metric is savings, target is 5% and within 3 months. The business case benefits is $6,000 per annum and the timeline is 3 months. So all the mandatory elements of the project charter are there. Then during the measure phase, I just collected the data. So how this $120,000 was spent on each year. So I had the data. So with that, I was able to find that the rent, food, and shopping. So these were contributing substantially for the problem. So for the rent, I could not do much about it because the house was nearer to my office and the schools of my children. But about the food, we ourselves were surprised when we found that we are spending $30,000 on food. So then we thought that we will do the project only on reducing the food cost. So by using the Pareto chart, we are able to narrow down the scope of the project. So once we decided that we will reduce the food expenses, then we had the data on month, how the money was spent on food. So here you can see that the minimum was around $1,650 and the maximum was $3,750. So this is an ideal problem that can be solved using the Six Sigma methodology because a lot of variability is there. Then during the analysis phase, we just started with the fishbone diagram or the cause and effect diagram to find out what are all the possible causes for the higher food expenses. And then we normally split it into man-related, material-related, machine-related, etc. And here I have just given what is the primary food, secondary food, outside food, and snacks and beverages. So these are the potential root causes. Then by using a tool which is called as the XY diagram, I was able to find that the meat, restaurant, ice creams, and chocolates, and oil. These are the four critical root causes which are contributing substantially for the food expenses. So typically in a Six Sigma project, these root causes has to be validated by using the statistical tools. So during the improve phase, in order to attend to this four critical root causes, I reduced the consumption of meat from twice a week to once in a week. From previously we were having meat both on Saturdays and Sundays. Now we decided that we will have it only on Sunday. Reduce the consumption of oil from 4 liters to 2 liters per month. Reduce the number of visits to restaurants from once in a week to once in 2 weeks. Previously, we were going to outside restaurant every week. Now we decided that we will go once in a fortnight. Reduce the consumption of ice creams and chocolate. So all these four actions resulted in an annual saving of $6,000. And also the health expenses reduced from $5,500 to $2,000. You may be wondering like why the health expenses went down, because all these four food items, they were not only contributing to the higher food expenses, since they were not very healthy, they were also contributing to the health expenses. So when I reduced all those consumption, then my health expenses also came down. So this is what will happen when you take a project in your own process. You take up a project to improve the productivity. At the end, you will find that the productivity has improved, your quality has improved, and your yield has also improved. You take a project to improve the yield. At the end, you will find that the yield is improved and the productivity also improved. So multiple benefits you will get by taking a Six Sigma project. So this is what is the before-after comparison. So before, you can see the average was quite high, variation was quite high. And after the project was completed, drastic improvement is there and variability also reduced. And now this is what is the current status. So my annual savings has increased to 10% of my salary for the last 5 years. And my expenses on health and loan repayments also have come down drastically. So again, since I was year on year, I was saving more and more. My loan commitments was coming down, and then that also helped me to come out of my issues. So multiple benefits you will get by doing the Six Sigma project. So now every year I enjoy the vacation with my family in an exotic location. And most important all, I can see happiness in my daughter's face during vacation, for which I can never fix a monetary value. So again, the customer satisfaction, employee satisfaction, these are very important for any organization, and we need to work towards it. So these are very simple example of how the DMAIC methodology can be used for solving the process problem. So again, as a green belt, as a yellow belt, typically you will be trained in the measure phase and the control phase, since you are going to collect the data from the process and the monitoring controlling the critical activities. So again, you need to make a detailed data collection plan. So what data you are going to collect. So whether you are going to note down the temperature, you want to note down the compressive strength, etc. So what measure you are going to name? What is the data type? What is the operational definition? Is a unambiguous description of the metric taken for improvement. Stratification factor, how you are going to present the data so that you will be able to get some meaningful information. Sampling notes, so whether you are going to take the samples on the entire population or only on some samples. So if it is for samples, how many samples you are going to take at a time and how frequently, who and how, who is going to collect the data and how they are going to collect the data. So you need to make a detailed data collection plan, and based on that, you can start collecting the data. So once you collect the data, again, if you are going to present the data in the rows and columns in the Excel sheet, maybe it is not, um, people may not understand what you are trying to communicate. So that is the reason you need to really understand how you can present the data in graphical format, because the human brain is tuned to absorb any information from the graphical picture, from the picture very easily when compared to any information from the text. So we again learn about the different graphical tools, and we also talk about the descriptive statistics. So by using some simple summary values like the mean, median, and standard deviation. So these are some of the summary values you calculate. So by which you will be able to present the data. So I will just give you an example. So we measure of central tendency, where most of the data points are likely to fall, mean, median, and mode, and measure of dispersion, how the data is varying by measuring the range, standard deviation, and variance. So again, this is an output of the Minitab, so which is a statistical software. So for example, we were just collecting the data on how the thickness of pizzas was varying in 4 different ovens. So there were 4 batch type ovens there in the pizza making company, and we found that their thickness was varying to a very great extent. Because of that, the scrap due to the burnt and uncooked pizzas were more. So we wanted to study where is the problem. So we wanted to really study whether oven to oven, how it is behaving. So by using a graphical tool, which is called as a box plot, which looks like this, then we can get a clear information. So the expected thickness is somewhere around 6.04. So this is what is the expected thickness. So again, the expected thickness, then how the different ovens are behaving. So the center line is the median, or where the most of the data points are likely to fall. So you can see that in oven 1 and oven 2, the average values are closer to the expected value. That means they are good. But oven 3 and oven 4, again, they are very far away from the target. So they are actually not doing good. And when comparing oven 1 to oven 2, you can see that there is a lot of variation in oven 2, whereas oven 1, whereas in oven 2, the variation is less. So instead of presenting 40 data points into 4 data sets, 160 data points were there, we cannot get useful information. But once we plot that into a box plot, then we are able to find out that O13 and O14, their mean was their average was quite higher when compared to the target, and O11, the variation was more. So whatever the data you are collecting in the measure phase, you need to know how you are going to present it in the graphical format, right? So for you that, again, you use the statistical software like Minitab. So again, the histograms, they are also a sort of a graphical tools. Maybe some of you might have seen that in your processes. So whenever you are producing something, as I was telling you earlier, some variation will always be there. So what is the extent of variability in the data, and where the peak or where the mean is there, that information you will be able to get by looking into the histogram. And the scatter plot is again a graphical tool that will help you to check if there is a relationship between two variables. So in this case, we had a doubt. We wanted to solve the problem of how to reduce the scrap because of uncooked and baked pizzas. And then we are able to prove that if the thickness is increasing, the percentage of the uncooked pizzas is increasing. So there is a strong relationship is there between these two. And since X is increasing, Y is also increasing, we call that a positive linear relationship. So we have a very strong linear positive relationship between the thickness and the percentage of uncooked pizza. And again, we have a strong negative linear relationship between the thickness and the burnt pizza. So by using these graphical tools like the box plot or a scatter plot, then we'll be able to infer a lot about our data. So in the control phase, again, as I was telling you, we need to closely monitor and control one or two critical inputs. So for that, again, we have already talked about the 5S. So by implementing the 4th and 5th S mainly, that is the Seiketsu and Shishuke, standardizing and sustaining. By using some of those tools, we will be able to sustain the improvements. And again, we learned a bit about the Pokayoke, also called as the mistake proofing. So that will help you to avoid manual errors. So again, you can see that these are all, when we talk about Pokayoke, these are all low-cost automation. So when I talked about the microwave oven shutting off or the washing machine shutting off when somebody is opening it, or the seat belt alarm coming when the seat belt is not worn. So for doing all this, again, we are not going for a very high cost automation. By using some sensors or relays or solenoid, by using some simple low cost mechanism, we will be able to get a foolproof system in place. So that's what is a Pokayoke. So after the improvements are completed in the improve phase, we will have to put in some Pokayoke mechanism in place so that we'll be able to sustain the improvement. And again, the statistical process control, also called as the control chart. So this tool will help you to closely monitor and control the critical inputs. So as I was telling you, one or two critical inputs or process condition, you want to closely monitor and control so that you will get a consistent output. So in order to do that, again, we will use the control chart, right? And then control chart is nothing but the metric what you want to control with respect to time. And then we need to ensure that all the points are within the limits. If all the points are within the limit, then our process is okay. If one or two points are going above or below the control limit, then there is a problem, right? So after the improvements are implemented, then by using the control chart, we will be closely monitoring, controlling the critical one or two inputs. And then the same control chart, again, we'll be using to check whether the output what you are getting is consistent. So again, as a yellow belt, again, that is the main responsibility of the yellow belt to monitor and control this critical input. Because maybe the other employees, they are not used to the Six Sigma methodology. So they may not be very sensitive to the accuracy of the data or the graphical tools or these control charts or Pokayoke. So that is the reason training is given to the yellow belts so that they will be able to help the green belt or the black belt project leaders. The last, again, one of the control mechanism is the control plan. So control plan is actually a plan which is going to give all the detail on what are the inspections and testing we are going to do on the product and on the process so that we will be able to get a consistent output. right? So, for example, right from the raw material. So what are the different parameters you are going to check on the raw materials, and what is the tolerance in which those parameters has to lie, how frequently you are going to take the sample. And then when it comes for the production or the operations, then at each and every process, what are the process parameters you want to control? What should be the tolerance in which the parameters should be controlled? And once the outputs are coming from the different sub-processes, then what should be the parameters that should be measured on the individual parts? What is the specification, right? So by controlling the different end-to-end sub-processes, by controlling the process conditions, and by measuring and taking the immediate corrective action, then we'll be able to have a consistent output. So for that, we can prepare the control chart, right? So that is very quick view about this yellow belt. So typically, more information and more analysis you will be able to do by getting into a green belt or a black belt this thing. So typically, any working professional who is having more than 3 years of experience, they can do a green belt certification, and people who are having more than 5 years, they can do the black belt certification. And definitely, this learnings will definitely help you to differentiate you from the rest of your colleagues, and definitely the quality of your work will definitely improve. So I recommend all of you to just get involved in this Lean Six Sigma and then come up quickly in your organizational ladder. Okay, so that's what I wanted to tell. And so if you have any doubts or any clarifications, you can just ask me.
Hi, sir. Thank you so much. I'm Venkatraman.
Yeah,
So you told about 5 years,
yeah,
it's,
yeah,
set, those
yeah. Say, say, don't say, yeah,
series from Seiko.
yeah.
So initially you told Six Sigma. So
Uh,
what is that? Is there any six elements or six components you did not cover? Because I understood DMAIC, define, measure, analyze, improve, and control. So there are only 5 elements. So
hmm.
what is that six?
No, Six
Six.
Sigma, again, there is a bit of statistics involved in that.
Okay.
So maybe like it has a correlation with the defect rate, right? So
Mm.
like, for example, normally most of the processes will be running at a 3 sigma level, where the defect rate is going to be some 67,000, 6.7%, right? So this is again purely, the Six Sigma is actually purely it is not six numbers, like five was, you can say, comes from the 5 Japanese words, is the Seiri Seton. But Six Sigma is a statistical measure. So that I will be able to explain more clearly when it has be some more statistics you need to understand.
Okay. Okay.
It is not actually
Okay.
6 different components.
Okay. Okay. So it's
Yeah.
a measurement
Yeah,
number.
measurement. Sigma is actually standard deviation, right?
Standard. That I know.
Yes,
That
yeah,
I
standard
know. So
deviation. So typically, when we talk about this normal distribution, is one of the statistical this thing. So you will find that the total variation will be within that 6 plus or minus 3 sigma, right? So,
okay.
for
Okay.
example, you are setting a machine at 10, then and your standard deviation is 1. So
Mm.
typically, you will get all the products between 7 and 13. So
Okay.
that's sort of this thing. Yeah.
Okay. And you also told Six Sigma is a data driven and
Yeah.
Lean Sigma is a
Lean management is a demand-driven approach.
demand driven. Okay.
Demand-driven.
Okay.
So you need to meet the changing demands from the customer. So that is where
Okay.
this thing will be helpful. Yeah.
Okay. Thank you so much, sir.
Yeah. Okay. Thank you. Okay. Okay. So with that, maybe if there are any doubts, then we can just it can get it clarified. So I think you will get the recordings and the PowerPoint presentations, and then you will also get the certificate latest by next Thursday, Wednesday, right? So all of
Hello,
you will
sir.
get the, yeah,
Sir, I have a question.
yeah.
Sir, what are the key roles of certifications like yellow belt, green belt, black belt in Lean Six Sigma, and how do they differ?
Yeah, as I told you, as I was explaining you, there are different levels there, right? So the white belt is actually the bottommost. So it is only some 2-3 hours of training. Whereas the yellow belt normally typically 1 or 2 days of training. So typically mainly on data collection and the controlling. Whereas the green belt and black belt, so they are actually the real problem solving tools, right? So you are going to be exposed to a lot of statistical tools. So this is what is the chronology, right? So these are the layer. So typically you should be somewhere, if you have more than 5 years of experience, so then it should be playing the role of a black belt. So then you'll be able to lead the Six Sigma project, and then you'll be able to save substantial amount for your organizations.
Yeah, sir, once upon a time I heard this green belt or black belt, we need to, reduce a certain amount, amount and increase the profit. So those kind of projects will only be, given for green belt or black belt. Is that true?
Yeah, that was actually a good question. So during the, like as I was telling, when 1987 to 1996, when Motorola and General Electric, they were implementing. So the target was to get a annual cost saving of around $200,000 for the black belt and $50,000 for the green belt, right? But again, on those days in those companies, all these project leaders and the project team, they were exclusively working only on the Six Sigma project, right? And they were able to achieve that. But nowadays, most of the organization, they want to the green belt or the black belt project leaders to do their regular work, and in addition to that, they also are supposed to do this Six Sigma project. So typically, this is left to the individual organization. So nowadays, not much emphasis is on that. So there is no, again, it varies from organization to organization.
Okay, so if I'm getting into this green belt or black belt training, I should implement the learnings I've learned in this training in my organization, right?
Yeah.
Okay.
So again, I think maybe we'll also be like, we are also organizing some like why you should select our institute for green belt or black belt certification. So that we will explain like how we make you learn all these tools and concepts. So normally we conduct it once in a month. So I think all the information will be given to all of you. So if you are interested, you can join that. So that again we are having some mobile app. We are going Minitab, this software you'll be able to get. So what are the different facilities and how the learnings are going to be there. So all those things we will explain. So this is actually purely wanted to keep it only as a information sharing.
Okay, so is there any cost involved or training fees we should pay for green belt or black belt
So
training?
that is a regular program. Yeah. So for that only, I think we are given the contact this thing. So we normally conduct one batch every month. So
Okay.
so again, that is because again that's, as I told you, this is a very very useful and very it will really help you to come up in your organizational ladder quite quickly.
Okay,
Hello,
sir.
sir.
Thank you.
Yeah.
Sir, can Lean Sigma be used for small projects or only for large organization?
No, it can be even done for the small organization also. Any type of organization is possible. Any size, any vertical, any function, everywhere it is applicable. So it's not limited. There's no limit for that.
Sir, what kind of problem or process are best suited for Lean Six Sigma improvement?
As I told you, like wherever you are having variation, right? Maybe today your process is very good, and then tomorrow suddenly you are facing some problems, right? So variations are there. So many cases it happens like that. So in those cases, you can use the Lean Six Sigma. Okay, then thanks all of you for joining this session, and then maybe we can catch up sometimes later. Okay, thank you. Bye.
Thank you, sir.
Thank you. Bye.